Hi, this is Trev and welcome to my blog. Undoubtedly the most asked questions is, should I invest in a TIG welder or a MIG welder? Well, I'm going to skew perception slightly by saying that really the question should be, should I invest in a MIG welder and a TIG welder? And this is what I hope to clear up over the next few episodes for you. I'm going to keep this one real short and sweet because I just want to give you that aha experience that I had a couple of years ago when I first picked up the TIG welder after being a long-term MIG welder user. And like I say, over the next few episodes I hope to be showing you the best that I can show you. I'm no expert at TIG welding, but what I will do is I will show you how I get the excellent results on sheet metal work, be it steel or aluminium. So like I say, this one, I'm just going to keep this short and sweet. This is all going to be about simple butt welding without using any filler rod. A few notes about setup. I've just fitted a heavy duty plug. I've connected the gas pipe to the rear of the welder, and up here is the main on and off switch. I have a 20 litre bottle of pure argon with an argon regulator attached to it and a flow meter so we can trim the gas perfectly. Straight off the bat, I'd just like to mention that the torch goes straight into the negative and the positive is for the earth, not the other way around. Always make sure you get that right, otherwise the welder won't work properly. The welder also comes with this accessory pack, so you've got a few cups, a few tungstens, etc. A nice little set of spares just to get us going. This is exactly what I'll be using to start with. Okay, I've just turned the welder on. I've made sure all our controls are turned off. So we've got everything turned off. This top switch here, MMA TIG, that's for stick welding. We've got it in the TIG position because we're going to TIG weld. AC DC, AC is for aluminium, DC is for steel, of course. On 2 TIG, I want to keep this absolutely as basic and as simple to start. We're going to start right at the beginning. So all we need is some base current. So I'm going to set the base current to 20, nice round figure for 0.9mm steel or 20 SWG as it's also referred to. Our post flow setting over here, I'm going to set the post flow up. I'm just going to give it a tiny little bit of post flow, and what that'll do is that'll just ensure that when I release the trigger, a tiny amount of gas will continue to come out. And what that little bit of gas will do is that will stop the tungsten from overheating, because if it's in a gasless atmosphere and it's still red hot, it will cook that tungsten, and also it will pick up contaminants. Once that tungsten is contaminated, then that will greatly affect the weld. So like I say, all we're looking at is base current of 20 and a little bit of post flow. We've got a bit of pre-flow already because it's set in the TIG mode, so no need to worry about pre-flow on the gas. Like I say, everything else is completely off. Let's just get started and let's keep everything as basic as possible. We can build upon this and then we'll have a greater understanding of how to use the welder. Put a nice sharp tip on the tungsten. Let's hope the camera will zoom in on that now. So we've got a nice sharp tip on the tungsten. I don't know how many degrees that is, and I've probably got more overhang or sticking out at the end of there than you probably used to seeing on other videos, but you can get away with far more than other people say. I'm going to set the flow meter to 7 to start with, and let's see. Let's do some welding. Make sure you wear your goggles, of course, when you're grinding, when you're welding. Make sure you wear your visor, have it well ventilated, always good to wear a respirator, etc, etc. Be safe, guys. Let's turn the welder on. It's so high frequency that even with the earth clamp disconnected, it'll still work. Of course, once we've got the earth clamp connected, then it will track down that high frequency spark and cause it to arc properly, which means that you haven't got to do the old-fashioned scratch start where you'd have to actually drive the piece into the workpiece to get the arc to start. Let's do some welding. So I'm going to weld these two pieces of steel together. So I'm going to hold the torch at this kind of angle, just off the upright, and pushing the weld along. What I'm going to do first is I'm just going to put a few tacks along these two pieces of metal just to hold them together. So I've ended up with a series of tacks all the way across the panel. I've probably gone a little bit overboard. I could have probably spaced those out every other one and it would have held it just as well. So the only place I'm going to use a bit of filler rod now is on the ends, because the heat absorption is far less on the very edge of the panel than it is in the centre of the panel, because you've got all that mass of steel soaking up the heat. Of course, as you travel towards the end, you've got less and less steel, and what tends to happen is you just end up with a great big hole appear right on the edge where you least want it. So what I've done is I've done a series of things. I put copper behind like I did with the MIG, but I haven't found this as successful a process, although it does work with TIG. But the easiest way I found is to get a piece of welding rod like that and connect it to the workpiece. So now instantly that welding rod is the workpiece because it's earthed out. And then as soon as you offer the end of the TIG up to the very end of the welding rod, then the welding rod instantly melts and starts shrinking back towards the panel. So you'll have a nice molten bead then let straight in to the joint on the end. You've got more of a build-up of weld, so the weld's less prone to just blow a great big section out of the corner. So we're all tacked into place, very little distortion. I'm just going to turn the amperage up very slightly. I think I'm going to give it 22 amps. I just feel like it could just use a tiny little bit more power, but it's all going quite well. It's all lovely and flush. Just make sure, obviously when you do your butt welding, just make sure everything's dead flush. So now I'm going to fuse the two sections together. I'm not going to use any welding rod. I'll start welding now, holding the torch in an almost upright position, just tipped over slightly, travelling in the direction of the weld, using very small circular motion. Let's see what it can do. Should weld itself together. Okay, all welded together. I did it in two basic hits. I should have done it in shorter runs and planished it in between. We got a little bit of heat distortion going on, but nothing I'm concerned about at all. I'll tap this up very quickly. The weld doesn't look anything that special, I can appreciate that. Let's zoom in and get a closer look. Also had a bit of a mishap here, because I got the doors open to try and create as much ventilation as possible without turning my extractor on. So if I turn the extractor on, you won't hear a thing. It was working well, but I had a gust of wind blow through the door. It actually blew the flame, the arc flame, and almost blew a hole. So not very good in windy conditions. So we're looking from the rear of the panel now, and this is the penetration we got on the other side, which I think's pretty good actually. It's pretty well sealed. Very much a self-sealing weld. If you get something that's as tight as this, the gap, then it almost welds itself together. Now that this has had 5 minutes to cool down, of course, it's straightened itself out hugely, so I'll just give it a tap up. Because it's TIG weld, it's beautifully soft compared to MIG weld. There's no hardness to the weld, well, nothing in comparison anyway. See, I've just flattened that weld out on the end. That's flattened out no problem at all. Same the other side. Because there's no weld bead there, because actually this will be undercut, I'll clean it up and show you what it looks like, but this will be very slightly undercut, but not as bad as you would probably assume. So let's clean it up, and I'm quite happy with how flat this is now. That's lovely and flat now, and you can see how little distortion it has. And it didn't take that long either, did it really? Okay, all cleaned up. This is the end result after cleaning up. When I tack welded the joint all the way along, I cleaned up half of the joint, and this top section is where I cleaned it up, and this lower section isn't where I wasn't. Now, the welding scale actually created contamination within the weld, and that's why there's these little craters. So it's always worth really cleaning anything up. If you've tacked it, just clean all that weld scale up. I should have cleaned up the two joints before I even started, because of course there would have been light oil and dirt contamination on the steel, but I just went for it. If I turn it over, this is the top side. We can see the craters worse here. There's also a crater right at the top, and that's where the wind gusted in through the door and blew the arc flame. So a lot of the old hand-built cars many years ago would have been gas welded together using no filler rod, and when I bear back to the original bodywork under these old cars, you can see there's plenty of undercut to all the welds. They haven't used any filler rod. I think we've just got much more sort of fussy in our expectations these days of trying to get things absolutely perfect. Incidentally, a lot of people will say that you have to use filler rod to bring the temperature of the weld down, otherwise the weld gets porous. As far as I'm concerned, this is a bit of a myth, because I think what people are basically talking about is when you're welding something that's 5mm thick, then of course you have to input far more heat into it. We're normally talking about oxygen acetylene welding, again stuff from the past of course, so they would have used loads and loads of heat, and of course it would have overheated the metal. They needed that heat for the penetration, so by putting the filler rod in, it actually brought the temperature of the weld down. But that's not what we're doing here. What we're doing is we're keeping the temperature at a nice steady temperature. We're not overheating anything, because it's so thin we instantly get the penetration we're after. So anyway, let's perform a strength test, see how well it stands up. Well, thanks very much for watching. I really hope you got something out of that, and I hope you had your aha moment, the same as I did a couple of years ago after being a long-term MIG welder. Something that I did forget to mention in the video was this auto darkening helmet that I used. Now, we use the £20 jobs that you can buy off eBay, and they're perfectly acceptable, the same as this mask. Perfectly acceptable. You can see when you're welding very well. But what this mask has over the ones at work, which really caught me off guard, was the ones at work, we've got skylights that light the workshop up really well, so you've got sunlight beaming through. Now if that sunlight casts across the visor front, you cannot see anything, and I'm not suggesting for one moment that it's actually activating the auto darkening, because it isn't, but just the sunlight on it stops you from seeing anything. If you stood near a doorway and there's sun coming through the doorway, you cannot see anything. If you get up underneath a wheel arch or under a car, you cannot see anything. Now when I was welding using this mask, I could leave the mask down all the time. It doesn't matter if I walk out into my garden or anywhere, it's absolutely crystal clear. I can see the whole time, and I haven't got to keep lifting that mask up to see where I am. Very useful thing to know, because when you're trying to position to weld, you really need to see where you're positioning. And sometimes I have even fired up the welder just so it creates an arc, so then I can then readjust my position, which isn't ideal. You really need to be able to see what you're doing all the time, and that mask has helped me with that. So anyway, all the products that you've seen are from Artec, and I'll put a link in the video description so you can go and check them out. This has been in no way a paid promotion. I'd just like to tell you that anyway. They've just literally helped me out with this equipment. Anyway, let's give away a cup from a couple of videos ago. So well done, Bob Hawg, or Bob Haig. I don't quite know how you pronounce it, but Bob, you are the winner, my friend. All you have to do to claim the prize is send me your address. In the video description to this video, there is my email address. Just simply let me know what your address is and I'll post this off to you at my own expense. Of course. How am I going to wrap this video up? I'd just like to say that Artec did a piece on me called Meet the Welder. I will put a link in the video description to that if you'd like to see a bit of a preview of the van, because there's a lot of pictures on there showing the van in its full, almost finished splendour. So if you'd like to check that out, just click on the link and you can go and see that. Anyway, I'm off for now. What am I going to do next time round? Well, in the next few videos, I'm going to show you more bells and more whistles and more techniques and more fine examples of great TIG welding, I hope. So I'll say bye for now.